So last time we looked at additive cipher, multiplicative cipher, and then we're going to look at something called affine cipher. And this particular affine cipher combines multiplicative properties at the same time. It also combines additive properties as well. So let's say we have a sender who wants to send a message. So what it will do, it will have pair of keys. So let's take an example. Let's say I have key and I have a pair of key 7, 2. There is a reason for it. Let's call this key K1. Let's call this key K2. So what it will do, it will take your plain text, which is your message. It will multiply by K1, take a mod with 26 using K1. And after that, it will take that message, whatever that you have received, whatever you have gotten through using K1, it will encrypt that again using K2. When taking a mod with 26, that would actually become your ciphertext. What sender will do, it will take your plain text or a message, it will multiply that message by K1, which is going to be this key 7 mod 26. Whatever the answer it will get, it will encrypt that again using K2, which is key 2, which is in our case is 2. And after that, that would become your ciphertext. It will send that to your receiver, which is Bob. Bob will take that key. What was the last operation which was done before sending this message? It was addition. So we're going to inverse that. So we're going to use additive inverse, which is subtract that K2 from that ciphertext. Then after that, what is the first procedure that was done? The first procedure that was done actually was multiplying the plain text with K1, which was 7. So it will take that message again, and it will multiply that by the key inverse of this and take mod with 26. So it will cause actually diffusion when you are sending, when the receiver. So if someone wants to encrypt that message, it will need some time. So this is known as affine cipher or affine transformation, where you'll take a message, you will encrypt with key 1, you will again encrypt with another key, you will send that message, then the receiver will also subtract that key K2, and then we'll take a multiply it by a multiplicative inverse of mod 26. Okay, the reason I have done that, so let's take a small message and try to encrypt that message first. All right, so I have my handy code book here. This code book is nothing. So as you will keep seeing this in additive cipher, like Caesar cipher and multiplicative cipher, where I just simply weighted the value of English alphabets. So for example, you can define any weight you want, any value you want to those English alphabets, but here in our case we're starting off with A all the way up to Z, assigning A to be 0 and all the way up to 25. All right, so this is what a code book is. It's just simply assigning values. So let's try to encrypt a message, and let's say our message or a plain text message or plain text is hello. How do I encrypt that message? So what is the first thing that I would do? I would look at my code book and I will see what does this map to. So here's my encryption process. I'm going to try to make this video short, so you will know. I will just do a couple of steps, and then you will learn how to do it. So the first thing I have to do is take my plain text. So let's define the value. So the first thing I have to do is what? Take that plain key. So here's my ciphertext for each. So what is the value of each? So we're going to go to our code book. Each is 7. So we're going to take that 7, multiply that by, what is this? Key 1. Key 1 is 7. And then we can bring this key in as well. And then I need to do what? Once I get this, because mod operation, I can use that once, that applies to all of them. So here's what I'm going to do. 7 multiplied by 7. This is the first part. Plus I'm going to add a key, which is key 2, which was right here. Whole thing mod 26. As we know, we will follow order of operation. We will do this first inside that bracket, then add 2, which is actually, so this is your key 1, this is your key 2. So this way we're going to do it. We're going to bring our calculator in. And so 7 times 7 would give me 49. 49 plus 2 would give me 51. So I'm going to use my mod operator. So 52 divided by 26 would give me 2. So that would give me what? Sorry, 49 plus 2 would give me 51. So 51 divided by 26, shift SD, that would give me 25. So 25, the top part is actually my remainder. So this would become what? 25. And 25, as per our code book, is actually Z. All right. So ciphertext for H would actually become Z. So I'm going to do the same thing real quick for E as well. So E has a codebook value of 4. So 4 multiplied by 7 plus 2, which is key 2, mod 26. So that would give me 7 times 4 is 28, 30 plus 2 is 30. So 30 divided by 26, that should give me 2, which actually means 4, because I'll have 4 as a remainder, because this is half of the value, so which means this is also going to be double. So 7 times 4 is 28, 28 plus 2 is 30, 30 mod 26, I'll get a remainder of 4. 4 corresponds to E in our code book. So this is E. Let's quickly do for L. So CL. L has a value in our code book. This is the value that I have assigned, like a weight for that particular letter. It's 11 times 7 plus 2 mod 26. Let's just quickly do it. So 77, 11 times 7 is 77. 77 plus 2 is 79. So 79 divided by 26. So shift, I get 1. 1 is actually 0, which means A. So 11 times 7. So L is 11. And then I have key 1 is 7. So 11 times 7 is 77. 77 plus 2 is 79. So 79, 26, 26, shift. So it would give me 1 actually, not 0, 1. So 1 actually corresponds to B. So 1 is actually B. If I do it again, I'll get the same thing because I have 2 L's. So let's just quickly do it for O. Because the reason I'm doing it, I want to show you something really important. So this is going to be the value of O as per our code book is 14. So 14 times 7 plus 2. So 14 times 7 plus 2. So let's quickly do it. 14 times 7, 98. So plus 2 is 100. 100 divided by 26. And shift SD. So 13, that means 22. Why? Because the denominator is 26, so it should be 26, but it's actually half of that, which means my quotient is going to be double of that, so which is 22. 22 corresponds to, as per our code book, is W. So my encryption for hello is actually going to be Z E. We got 2 W's, 2 L, sorry. So 2 times B and W. So this is going to be my encryption using affine transformation. All right. So now here's the tricky part. Not really a tricky part. So here's how the decryption will work. We'll just simply do one decryption just to show you. So the way we're going to decrypt this, we're going to take this. So the first step that I need to do in order for me to decrypt this is this. So the first step to do decryption is this. So in order for me to decrypt Z, I want to get my message back, or I want to get my plain text back. So what I'm going to do, the first thing I have to do is subtract. So Z has a value of 25. So that's my ciphertext. I have to subtract first word, the additive inverse of this, because this was the last operation, which means subtraction of key 2 is going to be the first operation, which is this. Then I need to multiply this. I need to put, because this is the first operation that I will do, so I'm going to put them in parentheses, and I'm going to do multiply that by key inverse. So how do I get my key inverse? So you can review the videos of multiplicative cipher, GCD, extended Euclidean algorithm. It's actually going to be the multiplicative inverse of this key. It's not going to be 1/7. So the multiplicative inverse, in last video we have calculated this to be 15. So 7 times 15. So the criteria for multiplicative inverse was that when we do extended Euclidean algorithm, and we will, the T1 value is going to be the value which is going to be the multiplicative inverse of this number. So the multiplicative inverse of 7 was actually, in last video we calculated to be 15. Why was that? Because there was a criteria, A multiplied by B congruent 1 mod n. So let's just check. 7 times 15 is 105. Divide that by 105, divide that by, or take a mod with 26 and shift SD, I get 1. So two number are multiplicative inverses of each other if they are relative prime, which means GCD of both of these number are 1. At the same time, when I fulfill that criteria where it was A multiplied by B congruent 1 mod n, I should get 1, and I am getting 1. So the multiplicative inverse, the key multiplicative inverse, key 1 inverse is actually 15. So we're going to use that 15 over here. So 15 mod 26. So let's quickly do that. So 25 minus 2 is actually 23. So 23 multiplied by 15. So 23 multiplied by 15 divided by 26. So 345 over 26, 7. So this would turn out to be 7. So I'm using this numerator value, which is 7. And 7, according to our code book, is H. So this corresponds to H. Let's quickly do another one. Let's do message P. Let's try to decrypt this. So this is going to be, so what is the value of E? E turns out to be 4. So 4 minus 2 multiplied by 15, which is the multiplicative inverse. So this is key 1 inverse, and this is key 2, which is this. So mod 26. So 4 minus 2 is 2. 2 multiplied by 15 is 30. 30 mod 26. 30 mod 26. So this value is half of that, which means my numerator is going to be double of that, so which is 4. So which is 4. So I'll get E, which is actually 4. And in this way you will perform your decryption process. Okay, the reason you have to still look at it, beside having two different keys, and one is multiplying, the other one is adding, we're still getting our encryption to be monoalphabetic. So it's not good. When a person is performing a frequency analysis attack, he will be able to know that this letter is continuously being repeated, which means I can do frequency analysis attack to find out why this letter is keep appearing, which means this is one of the very common letters in that particular text. So still monoalphabetic, not very much good, but even though we're using two different keys, but we're still getting monoalphabetic. So in upcoming videos we're going to do some type of polyalphabetic ciphers. They are still in a category of substitution ciphers, but they are not going to be monoalphabetic, which makes it harder, not in today's time, but it makes it harder to actually find out by just looking at the ciphertext that this might map to this particular letter. So I hope you like this small tutorial. If you have any questions, leave it in the comment section. Don't forget to subscribe to my channel.